Hi, and welcome back to S&M Makers. Today, we're going to start a journey to 20-color printing with the Neptune 4 Max. The Neptune 4 Max is a great printer, especially when printing large models. But Elegoo never released a multi-material system for it. While manual filament swapping has always been an option, manual swapping is slow and time-consuming, especially for prints requiring potentially hundreds or even thousands of swaps. Luckily, there are great third-party options available, and today we're going to start installing the ChromaSet from CoPrint. Getting 20-color printing working reliably is a lot of work, so we'll be starting with 8-color and expand from there. In today's video, we're going to walk through the mechanical installation steps and then cover the configuration and tuning steps in a follow-up video. CoPrint's ChromaSet is part of their new Series 2 product line, a new approach to adding multicolor printing capabilities to existing 3D printers. Instead of having an AMU or MMU that combines extruders, electronics, and material switching capabilities in a single box, the CoPrint Series 2 products are a collection of individual components that can be combined to form highly customizable multi-filament solutions. Unlike the more traditional approaches, the ChromaSet makes it easy to add just what you need for your printer. However, this flexibility does have a drawback. You need to mount and maintain a potentially large number of individual components and cables. The Series 2 product line consists of 5 main components. First is the ChromaPad, a tablet that can be used to upgrade a Marlin printer to Klipper, and also directly control the ChromaHead toolhead and up to 4 extruders. Since the Neptune 4 Max is already using Klipper, we don't need to use the ChromaPad. Instead, we're going to use the cheaper and smaller KCM. Like the ChromaPad, the KCM can control the ChromaHead toolhead and up to 4 extruders, but it isn't a tablet and doesn't have a touchscreen. To use the CoPrint system, you need to have either one ChromaPad or one KCM. Next is the ChromaHead, CoPrint's new toolhead, which has been designed specifically for multicolor printing. The most interesting part is the built-in cutting module that makes color swaps quicker and more reliable. To pass the individual filaments into and out of the system, the ChromaSet uses a set of CXI extruders. You need 1 extruder per color, so to get 20-color printing, you need 20 of these extruders. The final main component in the Series 2 product line is the ECM, which is basically a KCM without a connector for the ChromaHead. Each ECM adds support for another 4 colors, so 1 KCM and 4 ECMs are required for 20-color printing. Each component in CoPrint's Series 2 product line is packaged individually. Inside the KCM box, there's the KCM module, a 24-volt 5-amp DC power supply and power cord, a 1-meter USB-C to USB-A cable, and a product card. In the ChromaHead box, there's a ChromaHead, a mounting bracket, an 8-in-1 adapter, a 1.5-meter custom cable, 8 Bowden coupler claws and buckles, 3 each of M3 by 10mm, 16mm, and 20mm socket head screws, 2 M3 by 10mm button head screws, 3 each of M3 by 10mm, 16mm, and 20mm black socket head screws, 9 M3 square nuts, a 1.5mm and a 2.5mm hex wrench, a 7mm wrench, and a product card. Inside an ECM box, there's an ECM, a 5-in-1 adapter, a power cable Y adapter, 5 Bowden coupler claws and buckles, a 1-meter USB-C to USB-A cable, and a product card. And finally, in a CXI extruder box, there's a CXI extruder, a Sigma bracket, a custom 1.5-meter cable, 1.5 meters of PTFE tubing, 2 Bowden coupler buckles, 2 M3 hammer T-nuts, and 2 M3 by 8mm black button head screws. While today's video is primarily focused on the mechanical portion of installing the KCM set, you'll want to upgrade the firmware on your printer before you begin the installation. There are microcontrollers inside the KCM, ChromaHead, and ECM modules, which have been flashed by CoPrint with a fairly recent version of Klipper. Unfortunately, the version of Klipper in the Neptune 4 firmware from Elegoo is fairly old and not compatible. While you could risk downgrading the firmware in the CoPrint modules, or try installing Open Neptune on the printer, for these videos, we're going to use a custom version of Klipper I recently created to add support for modern printer modifications. The KCM set is actually what inspired me to create it. The printer we're going to be using today has already been updated to this custom version of Klipper. Since the exact steps to install the custom firmware can change as Klipper is updated, check the video's description for details and links to our previous custom Klipper installation videos. The KCM set can be installed on a wide range of different 3D printers, but the provided brackets and official 3D printable models are primarily geared towards Creality's Ender printers. As a result, the ChromaHead can't be directly mounted on the Neptune 4 Max using the provided bracket from CoPrint. But luckily, there are a few options to choose from. The first being an adapter provided by CoPrint in their Assembling Parts GitHub repository. This adapter attaches to the existing stock toolhead bracket and provides the 3-screw hole pattern required for mounting the ChromaHead. This adapter is fairly thick at 10 mm, so the nozzle in the ChromaHead will be moved about 5 mm forward compared to the nozzle in the stock toolhead. Also, since the ChromaHead's nozzle isn't centered along the x-axis like the stock toolhead, there's a loss of build area along the x-axis. Additionally, the adapter mounts to the existing stock bracket with just 2 small M3 screws, so it's potentially not the most secure. While the adapter is directly compatible with the linear rail kits from TBStron3D, you might have a problem using it with palm wheels because the voids for the eccentric nuts are a little too small. If your printer has palm wheels on the x-axis, but you still want to use the adapter, I created a modified version that increases the openings for the eccentric nuts. I also slightly increased the diameter of all of the screw holes to make mounting the adapter a little easier, especially if your printer isn't perfectly calibrated. Since all of our Neptune printers here at S&M Makers have been modded with linear rails, I wasn't really satisfied with using this adapter, so I created a new, custom, 3D printable bracket that replaces the existing X-axis linear rail carriage bracket from the TBStron3D linear rail kit. This new bracket moves the M5 threaded screw holes, so they are now compatible with the toolhead mounting bracket provided by CoPrint. With this option, the mounting adapter is no longer needed. Also, since the CoPrint provided bracket is about 17 mm narrower than the stock toolhead bracket, you don't lose as much build area along the x-axis. Unfortunately, this option can't be used if your printer has palm wheels for the x-axis. While this option does save build area, there is a drawback. The x-axis belt that connects to the toolhead bracket is too short for the CoPrint bracket, since the CoPrint bracket's belt mount points are approximately 13.5 mm closer than on the stock bracket. A longer belt will be needed, but these are easy to create and we'll cover the steps in this video. My custom bracket is 3D printed, but if you prefer a metal bracket, there's one more mounting option. TBStron3D and I worked together to design a new metal bracket that minimizes build area loss, just like with the printed bracket, but is also compatible with the stock X-axis belt, making it the easiest of 3 options to install. Additionally, this new bracket is compatible with the stock toolhead due to these extra 3 holes. If there is enough interest, TBStron3D plans to make this bracket available in their store. Unlike with MMU and AMU solutions for multi-filament printing, the KCM set requires mounting up to 20 extruders on or near your printer. This can take up a lot of space and can get a bit complicated, depending on where you place your printer and how much free space you have. While the CXI extruders each come with a mounting bracket, Using them to mount 8 or more on a Neptune 4 Max is a bit tricky and not really practical on a smaller printer. For this video, I created a custom extensible extruder mount that stacks the extruders. Currently this mount is not compatible with the built-in Z mod from TBStron3D, but if there's enough interest, I'll create a new version that is compatible. You can also probably find other extruder mounting options online. A stock Neptune 4 Max printer has a large auxiliary fan that provides extra cooling, but many people choose not to use it. During the ChromaSet installation, the auxiliary fan needs to be removed to access the X-axis belt. Especially since the ChromaHead was designed without knowing about the Neptune 4 series specific auxiliary fan, if you've been thinking about removing it, now might be a good time. The ChromaHead connects directly to the ChromaPad or the KCM with a custom 4-conductor cable, and doesn't use the main cable used by the stock toolhead. During installation, you'll need to decide what to do with the main cable, and if you choose to not reinstall the auxiliary fan, what to do with its cable as well. You could just leave the cables hanging off the side of the printer, or tie them to your existing cable holder. But if you don't like those options, I created a simple bracket that attaches to the X-axis gantry and lets you zip tie the cables along the gantry. These are good options if you think you might revert back to stock at some point. However, today, we're going to remove the cables. While it's extra work and requires minor printer disassembly, the end result is much cleaner. Additionally, during the install, the filament spool holder and runout sensor will be removed. While the runout sensor wire can easily be left as is, we'll cover removing it as well. Some common tools and supplies will be required to install the KCM set. These include 2mm, 2.5mm, and 3mm hex wrenches, side or flush cutters, and a small pair of pliers. A crafty utility knife could be helpful for moving the X-axis belt out of the way while disconnecting it from the toolhead bracket. The knife can also be used for cutting the PTFE tubing, but a dedicated PTFE tubing cutter is a safer and easier option. Since the PTFE tubing provided with the CoPrint modules is translucent, but white, you might want to use clear PTFE tubing instead, to give the install a nicer look and to make it easier to identify filament colors. Also, since the included Bowden couplers are kind of small and easy to damage, having a few spares on hand might be a good idea. There will be a lot of times when you'll want a tape measure or a ruler, and a meter stick might make measuring the PTFE tubing less of a hassle. Especially if you decide to remove the stock wiring, you'll need 20 or more lightweight zip ties. A couple of toothpicks might be helpful when lining up square and T-nuts, and an 8mm socket will be needed for removing the toolhead if your printer has palm wheels. While optional, a short right-angle USB 3 cable will make the final installation a bit neater. If you decide to remove the old stock wiring, you'll also need a small flathead screwdriver for removing cable covers, loosening wires, and inserting contacts. To match the look of the stock wiring, 1/2-inch braided nylon sleeving is also needed, along with black gaffer tape. A cigarette lighter will be used to prevent the sleeving from fraying, and scissors are probably the easiest option for cutting the sleeving to length. Masking tape, a wooden coffee stirrer or similar, plus a wooden dowel or stick, will make preparing the new wiring easier. With the stock toolhead cable removed, your current X-axis gantry cable clamp might not work as well. That's why I designed a brand new clamp specifically designed for the ChromaHead and auxiliary fan cables. This clamp is very compact and reduces the chance it could hit the diagonal brace. The PTF tubing provided with the extruders doesn't like to stay straight because it's been sitting tightly coiled in the boxes. Print at least one PTFE holder available in the CoPrint assembling parts repository before you begin the installation to help keep the installed PTFE tubing looking neat. Links to all models are available in the video's description. To protect the printer from falling objects, you're also going to want a piece of cardboard or foam core that's just larger than the bed. Lastly, unless you only want to set up 4-color printing and you're not already using your printer's USB port for a webcam or some other add-on, then you're going to need a USB hub. I recommend getting one with at least 7 ports, so even if you're going to set up 20 color printing, you'll still have 1 or 2 ports free. According to multiple users on the CoPrint Discord, you probably want the hub to support the MTT or Multiple Transaction Translator feature. This is getting into the very low level details of how USB works, but basically it might improve the communication between the CoPrint modules and the printer, decreasing the chance of communication issues. Unfortunately, even if a USB hub does support the feature, it's rarely listed in the product description. The same users on the CoPrint Discord say Anchor and Orico are the most likely to support MTT. I found this hub on Amazon and confirm it does support the feature. To prepare the custom 3D printed X-axis linear rail bracket, you'll need a printed bracket, 2 M5 by 4mm heat set threaded inserts with a 7mm outer diameter, a soldering iron, and an M5 heat set insert tip. While the tip technically isn't required, it does make installing the inserts easier. Also, during the video, I'll be using a heat set insert press, but a regular soldering iron works just as well. You just need to keep it as straight as possible. To install the inserts into the bracket, insert the narrow ends of the inserts into the holes, making sure the inserts are level. Then, with your soldering iron heated to about 10 to 15 degrees above your normal printing temperature, slowly press the inserts into the bracket so the wide end is flush with the side of the bracket. To make the new belt, a 1148.5mm piece of Gates 6mm wide GT2 belt material and 2 belt clamps are needed, along with a standard pair of pliers. To begin, insert the belt into a clamp with the 2 sides facing up. Now use the pliers to pinch one side of the clamp, and then repeat for the other side. Finish by squeezing both sides together. Follow the same steps for the other clamp. The 3D printed extruder mount that we are using today requires 12 printed parts when mounting 8 extruders, including 1 base, 1 second level, and 10 standoffs. 20 M3 by 4mm heat set threaded inserts with an outer diameter of 4.6mm combined with 20 M3 by 12mm button head cap screws will be used to hold all the parts together. An M3 heat set insert tip combined with a soldering iron will make installing the inserts easier. There are 3 different hardware configurations for mounting the extruder mount to the printer. When the stock filament holder is removed, 2 slide-in M4 nuts are left behind. One mounting option is to use 8 M4 by 14mm button head cap screws, 8 M4 washers, 6 M4 hammerhead T-nuts, and the leftover slide-in T-nuts. While this is the preferred approach, it does require having M4 hammerhead T-nuts available. The next option uses 8 M3 by 14mm button head cap screws, 8 M3 washers, and 8 of the M3 hammerhead T-nuts that are included with the extruders. This option requires the least amount of additional hardware, but either the 2 M4 slide-in T-nuts from the filament spool holder need to be left as is, or extra printer disassembly is required to remove them. A middle ground third option uses M3 hardware for 6 of the 8 spots. In the remaining 2 spots, M4 screws and washers are used with the stock slide-in T-nuts. In this video, we'll be using the all M4 hardware option. Links to all 3 model variants are in the video's description. Start the assembly process by installing 2 heat set inserts into each standoff, using the same approach we used for the X-axis gantry bracket. Now let's start on the base. using a 2.5mm hex wrench, disassemble 4 extruders, and reassemble them with the mount sandwiched in between, taking care not to strip anything or damage the plastic gears. Next, use 10 M3 by 12mm button head cap screws to attach the standoffs to the base. Then install 6 M4 by 14mm button head cap screws, 6 M4 washers, and 6 M4 T-nuts into mounting holes 1, 3, 4, 5, 6, and 8, making sure to keep the nuts as loose as possible. Finally, pre-install M4 screws and washers into holes 2 and 7. Install 4 more extruders into the second level the same way, but do not connect the standoffs. If you choose to remove the stock wiring, you'll have another choice to make. Since the filament runout sensor cable and the LED cable are connected, and the LED cable will still be needed to control the LEDs. The fastest and easiest solution is to simply pull the cables apart. However, I'm not a fan of making permanent modifications to my printers, so instead, we're going to create and install a new LED cable. To create the cable, you'll need a 69.5cm long piece of 2-conductor 24-gauge ribbon cable, 2 2-pin JST XH female housings, and at least 4 contacts. While the cable only needs 4, I recommend having at least double on hand since they are easy to damage. While technically not required, you'll probably want a pair of wire strippers to make stripping the wires easier, a crimper to simplify crimping the contacts, a loop for verifying the crimps, and a small screwdriver in case the contacts don't want to go into the housings. The LED cable uses JST XH connectors, which require crimping contacts onto each conductor. Before the contacts can be crimped on, however, the ends of the wire need to be split. On each end of the wire, pull the conductors apart approximately 10 millimeters. With the wire split, we can now strip about 1.5 millimeters of insulation from each conductor. To install a female connector onto the end of the wire, first place a contact in your crimping tool and then insert a conductor into the contact. The wire should be inserted just enough so the strands are just past the end of the middle section of the contact. The insulation should be fully within the end section of the contact, but not in the middle. Squeeze the ratcheting crimping tool to crimp the contact. Repeat for the other conductor. To finish attaching the connector, insert the contacts into the female housing. On the housing, one side has a small notch to indicate pin 1. If your ribbon cable has markings on one of the conductors, make sure that conductor is inserted into the opening for pin 1. The cable needs to be straight through, meaning pin 1 connects to pin 1 and pin 2 connects to pin 2. Repeat for the other connector. If you decide against removing the stock wiring and want to use the X-axis gantry bracket, you'll need 4 M4 by 12 mm button head cap screws and a few zip ties. We are now ready to begin the installation process. Step 1. Turn on the printer. Step 2. Navigate to Fluid and verify the printer is using the custom version of Klipper. Use G-code M115 to display the Klipper version. Then navigate to the System tab and scroll to the version field in the MCU RPI section. You should see S&M Makers, V12, or V13. If you see V10, then you're probably still on stock firmware. Step 3. Remove any filament from the printer. Step 4. Use the LCD controller to set the Z offset to 0 and save. Step 5. Raise the gantry to the halfway point along the Z-axis. Step 6. Use Fluid, Mainsail, or SSH to shut down the printer. Step 7. Turn off the printer. Step 8. Disconnect power. Step 9. Disconnect the network cable. Step 10. Remove the LCD controller. Step 11. Place a protector over the build surface. Step 12. Disconnect the main cable from the toolhead and auxiliary fan. Step 13. Remove the auxiliary fan using a 2.5 mm hex wrench. Step 14. Use the belt tension knob to loosen the X-axis belt. Step 15. Disconnect the X-axis belt. Sometimes a utility knife can be helpful for pulling down the belt, making it easier to remove. Step 16. Disconnect the filament runout sensor. Step 17. Remove the filament runout sensor using a 3 mm hex wrench. Step 18. Remove the filament spool holder using a 2.5 mm hex wrench. Step 1. Remove the stock toolhead by using an 8 mm socket and a 3 mm hex wrench to loosen the top 2 palm wheel nuts. Step 1. Remove the stock toolhead using a 3 mm hex wrench. Step 2. Separate the stock toolhead and the stock toolhead bracket using a 2 mm hex wrench. The stock toolhead, cable strain relief, and screws will no longer be used. Step 2. Separate the stock toolhead and the stock toolhead bracket using a 2 mm hex wrench. The stock toolhead, cable strain relief, and screws will no longer be used. Step 3. Reattach the stock toolhead bracket using an 8 mm socket and 3 mm hex wrench. Step 3. Reattach the stock toolhead bracket using a 3 mm hex wrench and 2 previously removed M5 by 6 mm button head cap head screws. Step 4. Reconnect the X-axis belt. Step 5. Tighten the X-axis belt. Step 6. Reattach the auxiliary fan using a 2.5 mm hex wrench and 4 previously removed M4 button head cap head screws. The screws are 50 mm long if you have palm wheels and 40 mm long if you have a linear rail. Step 7. Attach the tool head mounting adapter using a 2 mm hex wrench and 2 black M3 by 10 mm button head cap screws. Step 8. Attach the ChromaHead using a 2.5 mm hex wrench, 3 black M3 by 10 mm socket head cap screws, and 3 square nuts. A toothpick and a small pair of pliers can be helpful for aligning the M3 nuts. Step 1. Remove the stock tool head using a 3mm hex wrench. Step 2. Remove the linear rail carriage bracket using a 2.5mm hex wrench. Step 3. Install the new linear rail bracket using a 2.5mm hex wrench and 4 previously removed M3 by 5mm socket head cap screws. Step 4. Disconnect the X-axis physical end stop switch if you've installed that mod into your printer. Step 5. Remove the 2 end caps, tensioner, and tensioning knob using a 2mm hex wrench. Step 6. Remove the stock X-axis belt. Step 7. Install the new X-axis belt. Sometimes the belt clamp will get caught on a screw. Wiggle the belt and it'll eventually make it through. Step 8. Reinstall the end caps, tensioner, and tensioning knob using a 2mm hex wrench and 5 previously removed M3 by 6mm flathead cap screws. Step 9. Reconnect the X-axis physical end stop switch if installed. Step 10. Attach the CoPrint toolhead bracket using a 3mm hex wrench and 2 previously removed M5 by 6mm button head cap screws. Step 11. Connect the X-axis belt. Step 12. Tighten the X-axis belt. Step 13. Reattach the auxiliary fan using a 2.5mm hex wrench and 4 previously removed M4 by 40mm button head cap screws. Step 14. Attach the ChromaHead using a 2.5mm hex wrench and 3 black M3 by 10mm socket head cap screws. Step 1. Remove the stock tool head using a 3mm hex wrench. Step 2. Attach the TBStron3D bracket using a 3mm hex wrench and 2 previously removed M5 by 6mm button head cap screws. Step 3. Connect the X-axis belt. Step 4. Tighten the X-axis belt. Step 5. Reattach the auxiliary fan using a 2.5mm hex wrench and 4 previously removed M4 by 40mm button head cap screws. Step 6. Attach the ChromaHead using a 2.5mm hex wrench, 2 black M3 by 10mm socket head cap screws, and 1 M3 by 6mm socket head cap screw. Step 1. Remove the upper zip tie using a pair of side cutters. Step 2. Remove the Z-axis motor zip tie using a pair of side cutters. Step 3. Remove the printer base zip tie using a pair of side cutters. Step 4. Remove the horizontal cable cover using a small flathead screwdriver. Step 5. Remove the vertical cable cover using a small flathead screwdriver. Step 6. Disconnect the filament runout sensor cable. Step 7. Disconnect the LED cable. Step 8. Remove the filament runout sensor and LED cables. Step 9. Connect the new LED cable to the LED strip. Step 10. Install a new upper zip tie using a pair of side cutters. Step 11. Install the new LED cable. Step 12. Reinstall the vertical cable cover. Step 13. Install a new Z-axis motor zip tie using a pair of side cutters. Step 14. Connect the new LED cable to the printer. Step 15. Install a new printer base zip tie using a pair of side cutters, making sure to not secure the filament runout sensor cable. Step 16. Remove the printer base main cable clamp by pinching the sides. Step 17. Disconnect the X-axis physical end stop switch if installed. Step 18. Disconnect the X-axis motor. Step 19. Remove the X-axis gantry main cable clamp using a 2.5mm hex wrench. Step 20. Remove the storage tray. Step 21. Prop the printer on its side. Pads or blocks could make this step easier and safer. Step 22. Remove the bottom panel using a 2mm hex wrench, being careful to not damage the main board fan cable. Step 23. Disconnect the main board fan. In the following steps, a number of connections to the printer's mainboard will be removed. Unfortunately, the connectors might be covered in hot glue, which needs to be removed first. This hot glue can be peeled away from the mainboard using pliers, but go slow and be very careful, since it's easy to tear off small components and damage connectors and wires. Focus on small areas at a time and use twisting motions, instead of just directly pulling away from the mainboard, and the hot glue should eventually come off. The connections to be removed include the nozzle heater, the model and auxiliary fans. Both are plugged into the same connector with a Y adapter. The printhead fan, the Z-probe, the filament runout sensor, the nozzle thermistor, the toolhead LED, the X-axis accelerometer, and the extruder motor. Step 24. Disconnect the heater using a small flathead screwdriver. Make sure to retighten the screws once the wires have been removed. Step 25. Disconnect the fan 2 Y adapter. Step 26. Disconnect the printhead fan. Step 27. Disconnect the Z-probe. Step 28. Disconnect the filament runout sensor. Step 29. Disconnect the nozzle thermistor. Step 30. Disconnect the toolhead LED. Step 31. Disconnect the X-axis accelerometer, being very careful to not damage the Y-axis accelerometer cable or connector in the process. Step 32. Disconnect the fan 2 Y adapter. Step 33. Reconnect the auxiliary fan. Step 34. Disconnect the extruder motor. Step 35. Remove the 5 zip ties securing the main cable. Step 36. Remove the main cable, being careful to not damage the X-axis motor, auxiliary fan, and if installed, X-axis physical end stop switch cables. A wooden coffee stirrer or other small flat object can be helpful for separating the tape on the sleeving from the cables. Step 37. Prepare new 1/2-inch diameter sleeving by first cutting to 78 centimeters and then using a cigarette lighter to slightly melt the cut ends. Step 38. Insert the X-axis motor, auxiliary fan, and if installed, X-axis physical end stop switch cables into the new sleeving. Using a stick and masking tape can make the process a little easier. Step 39. Apply gaffer tape to the ends of the sleeving to prevent it from falling down. Position the cables so the auxiliary fan cable is extending 43 centimeters past the end of the sleeving. The physical end stop cable is extending 17 centimeters past the end of the sleeving, and the X-axis motor cable is extending 12 centimeters past the end of the sleeving. Apply an approximately 1-inch wide piece of tape on the end of the sleeving furthest from the printer, making sure half is over the sleeving and half is over the wires. Now, ensure the cables in the sleeving are straight and not punched up. Then apply a piece of gaffer tape to the end of the sleeving closest to the printer. This piece of tape should only be touching the sleeving. Step 40. Install 5 new zip ties to secure the various printer cables, making sure to not secure the filament runout sensor cable. Trim the zip ties to length using a pair of side cutters. Step 41. Remove the filament runout sensor cable. Step 42. Reconnect the mainboard fan. Step 43. Reinstall the bottom panel using a 2mm hex wrench, 10 previously removed M3 by 14 button head cap screws, in 10 previously removed M3 by 6 mm button head cap screws. Remembering the shorter screws go in the middle and the longer screws go in the left and right sides. Step 44. Turn the printer upright and remove any support material. Step 45. Reinstall the storage tray. Step 46. Reconnect the auxiliary fan. Step 47. Reconnect the X-axis physical end stop switch, if installed. Step 48. Reconnect the X-axis motor. Step 49. Reinstall the printer base main cable clamp. Step 1. Connect the custom tool head cable to the ChromaHead. Step 2. Secure the tool head cable using a 2 mm hex wrench and 2 M3 by 10 mm button head cap screws. Step 3. Install 8 PTFE claws in the 8-in-1 adapter. Step 4. Attach the 8-in-1 adapter to the ChromaHead. Step 5. Connect the tool head fan to the ChromaHead. Step 6. Attach the ChromaHead cover to the tool head. Step 7. Install the new X-axis gantry cable clamp using a 2.5 mm hex wrench and previously removed M4 by 8 mm button head cap screw, ensuring the tool head and auxiliary fan cables can move freely. Step 8. Cut 4 pieces of the PTFE tubing in half. Each piece of the tubing is approximately 1,530 millimeters long, so each half piece should be roughly 765 millimeters. It's okay if the pieces are not all the same length, since most pieces will be slightly too long anyways. Use the longest pieces for the extruders on the top and the ends. Once the printer is back working again, the PTFE tubing can easily be trimmed down as desired. Step 9. Install the first 4 extruders. Start by aligning all of the hammer T-nuts. Then position the slide-in T-nuts, if using M4 hardware. Loosely tighten 1 or 2 of the screws with a 2.5 mm hex wrench, and then install the 2 additional M4 by 14 mm button head cap screws and M4 washers. Use a ruler to ensure the extruder mount is centered, and then tighten all screws. Step 10. Install PTFE tubing into the first 4 extruders. Then install 4 buckles to prevent the tubing from being removed. Step 11. Install the remaining extruders using a 2 mm hex wrench in 10 M3 by 12 mm button head cap screws. Step 12. Install PTFE tubing and 4 buckles into the second set of 4 extruders. Step 13. Install the PTFE tubing in 8 buckles into the 8-in-1 adapter, starting with the center location. While it's possible to remove the buckles later on from the 7 outer claws, the center buckle will kind of be locked in place unless you first remove an outer claw. Step 14. Install a PTFE clip. If you want to install more than one, it might be easier to wait until the printer is working again and the PTFE tubing has been trimmed as desired. Step 15. Connect the 8 custom cables to the extruders, making sure to use the cable ends with the larger connectors. Step 16. Connect the cables for the first 4 extruders to the KCM. The connector for the first extruder is closest to where it says KCM, and the connector for the 4th extruder is closest to the CoPrint logo. Step 17. Connect the cables for the second 4 extruders to the ECM. The connector for the 5th extruder is closest to where it says ECM, and the connector for the 8th extruder is closest to the CoPrint logo. Step 18. Install 4 zip ties, securing the extruder cables to the diagonal brace closest to the X-axis motor. Cut the length with a pair of side cutters. Step 19. Connect the power Y adapter to the KCM and ECM. Step 20. Install a zip tie on the power Y adapter to prevent the cable from splitting. Use a pair of side cutters to trim to length. Step 21. Connect a USB cable to the KCM and another to the ECM. Step 22. Join the right angle USB cable with the USB cable provided with the USB hub. Step 23. Plug the right angle cable into the printer and position the 2 USB cables under the printer. Step 24. Plug the USB cable into the hub. Step 25. Plug the USB hub's power adapter into the hub. Do not plug the power adapter into the wall at this time. Step 26. Plug the ChromaSet power cable into the ChromaSet power adapter. Step 27. Connect the ChromaSet power adapter and power Y adapter. Do not connect the power adapter to the wall at this time. Step 28. Reconnect the network connection. Step 29. Reconnect power to the printer, but do not turn on the printer at this time. Step 30. Remove the build surface protector. Step 31. Reinstall the LCD controller. Well, that's it for the mechanical installation steps. In our next video, we're going to turn on the printer, connect the KCM and the rest of the ChromaSet, configure Klipper, and then finally be able to start printing in 8 colors. In our third video, we're going to try to make it all the way to 20 color printing. I hope you found this video helpful, but if you encountered any problems or you have any comments or questions, let us know in the comments below and we'll do our best to help you out. And as always, thanks for watching.